Okay, in my last video, we had a look at this mmWave sensor used as a human presence detector. So if you mount the sensor on a wall in a room and somebody enters the room, this LED will turn on, and when they leave the room, this LED will turn off. So the sensor is very reliable, easy to use, inexpensive. No need for a microcontroller or coding. You could use it in standalone mode. So instead of driving an LED, you could drive a relay to control a light or any other device. Now, as a bonus, if you hook up an FTDI module that's USB to serial and you monitor the TX pin, it will be streaming range data. So it will give you the distance from the sensor to the person in the room as they're moving around the room. Now in this video, we're going to have a look at another sensor, very similar to this one, but it's more advanced. It's called the Rd-03D. Okay, here's the Rd-03D mmWave sensor that we're going to have a look at today. And you can see it's more advanced. It's got an antenna array on the front. And there's two ways to connect. There's a JST connector and there's solder pads. Now when you order this module, try to get the connector with the pigtails because it's kind of hard to find. So it just plugs into there. Or you could solder on a single pin headers onto those pads like I did here. And then you just plug that into a breadboard. It's breadboard friendly. So either way, you go that way or go with the connector. So next we're going to have a look at the differences between this mmWave sensor and the first one that we had a look at, the simple one, and see the differences for your projects. Okay, here's a room that we want to monitor, and we're going to use our first sensor, our simple one. So we attach it to the wall right here. Now when somebody enters the room, we're going to get presence detected. Now if that person walks into the room, say it stands right in front of the sensor right here, it's going to give us a distance from here to here. So say that's 500 centimeters. Now if that person walks over to here, it's going to be the same distance, or over to here. It's going to be the same distance as if he was standing in front of it. Same as if he's standing over here, it's going to give the distance from here to here. That's the simple sensor. So next we're going to have a look at the other sensor, the more advanced sensor. Okay, next we are going to monitor the same room using the more advanced sensor, and we're going to apply it to the same area, to the front right here. So now when a person enters the room, we're going to get a presence detected, and if that person walks into the room and stands right here, the sensor will give us this distance from the sensor to here. It will also give us the offset from here to here. So now we know this distance. And this distance, we could calculate the hypotenuse, so a squared plus b squared equals c squared. So now we know the distance from the center to the person. We could calculate this angle. It's arctan of opposite over adjacent. So now we know the angle, and we know the distance to this person. Now if this person is moving towards the sensor or away from the sensor, it will detect which direction he's going and the speed. So this sensor is a tracking sensor. It's a human tracking sensor. So as a person moves around the room, we could always track it. We could get a reading, angle from the center line, and a distance and the speed. Okay, I have a little demo set up to show you how the sensor could detect the offset, the left or right offset. So right now I'm standing in front of the sensor, and on the SCAMP board the LED is in the center. So as I move, it's going to track me. So I'm going to move to the left. So I'm moving to the left slowly, and it's tracking me. And I'm at the far wall. So I'll come back. I'll come back to the center of the sensor, and I'll go to the right wall. Go over to the right. So I'm over to the right. I'll go back and forth fast. Over to the left. And go over to the right. So it's tracking me. Come back to the center. It's tracking me without any moving parts. Okay, next we're going to have a look how we can extract the data from the sensor. So the sensor is sending out frame packets continuously, which are UART compatible at 256K baud, 1-stop bit, no parity bits. So you can see the start of the frame. The frame header is 4 bytes, AAFF0300. Then we have target information 1, 2, 3, so we can actually monitor or track 3 people in a room. Then end of frame is 55cc. And if we go down, here's an example. So AAFF0300, that's the start of the packet. Then we have 0E03, That's the X offset. Then we have B186. That's the distance from the sensor to the target. Then we have 1000. That's the speed. So if the target is moving towards the sensor or away from the sensor, it'll give the speed in centimeters per second and the direction, either minus or plus. Then we have 4001. That's the range gate length. Then we have target number 2, which is all zeros because we don't have a second target or a third target, is all zeros. Then the very last is a 55cc. That's end of packet. Okay, I got TerraTerm up and running on my computer. It's connected to my SCAMP board, which is monitoring the UART output of my sensor. So we're going to have a look at some simple parsing. So look at some packets. So I'll go print raw. So here's the packets coming out of the sensor. And you can see it starts with the header. You can see the AA. And then we got FF. And then 0300. So there's our start. And here's our end of packet, 55cc. And all these zeros here is our target 2 and 3, which we're not using. And so we're using this data here for our project. Right there. That's the data we're going to be using. Okay, next, we're going to have a look at our offset. That's our X value. So I'll print offset. And I'm standing in front of the sensor and moving to the left. You can see it's positive. I'm at the left wall. Now move towards the center of the sensor, and you should go to 0 and then go negative as I go on the other side to the right of the sensor. Okay, next we're going to have a look at speed. So I'll go print speed. Okay, I'm standing about 5 feet away from the sensor. I'm standing still. You can see it's 0. Now I'm going to run towards the sensor. I'm going to run fast towards the sensor. You see I get a negative. Now I'm stopped. I'm right at the sensor. Now I'm going to run away from the sensor and we should get a positive reading. That's away from the sensor. I'll do it again. I'm standing still towards the sensor. Stop. Away from the sensor. Stop. Okay, next, we're going to have a look at our Y value. That's our range. That's our distance to target. So I'll go print range. And I'll get up and I'll slowly move back. And it should increase as I move further back. Stop. I'll come forward, back towards the sensor, and the value should drop. So I come closer and closer, and we're back to the sensor. Okay, so that was my little tutorial on how to get this mmWave Rd-03D up and running. Should be enough information to get you going. All you need is a microcontroller with a UART, connect it up to the RxTX pins, stream the data, parse it, and see what kind of projects you could come up with.